So let's add a couple of more points to this choreography of climate and health. This is a map that is showing the number of months currently worldwide where the distribution of mosquito Aedes aegypti occurs. So we are looking at number of months here going from just 1 month or less to throughout the year. Obviously you can see the red band here across the tropics where the temperatures are favorable for the mosquitoes to breed and survive throughout the year, which obviously favors the occurrence of tropical diseases like dengue fever, Zika, chikungunya, and yellow fever throughout the year. Obviously, people from higher latitudes are always very careful and have to get yellow fever shot, malaria shots, and so on when they travel to the tropics. So what happens if we just exceed the Paris Agreement goals by 2080? And obviously tropics don't change that much, even though you can see some changes up here in the Himalayan foothills, for example, and in the Saharan region. But you can see that there are drastic changes up here in higher latitudes where you see now regions which had no mosquito survival are beginning to have, especially up here. You can see that this region has grown tremendously in terms of the mosquito survival in the year. And even 1 month of survival is obviously enough to create havoc in terms of disease outbreaks. So considering the fact that with general trend in temperature, the tropics are expanding, mosquitoes are moving north anyways, and some tropical diseases are appearing in higher latitudes, as I said before, in terms of chikungunya in Italy, Lyme disease in the US, and so on. This is not good news, of course. Okay, so that's the human ecology of how mosquitoes, vegetation, temperature change, precipitation change, humidity change, human travel, etc. are going to spread the diseases and change the dance between climate and human health. This is showing percentage increase in daily death rates for New York City, and obviously as you get colder there is increase in mortality, death rate, but as you get hotter obviously there's a much sharper increase in percentage in death rate, daily death rates. So the comfort zone lies somewhere between 17 and 22 degrees here. The steeper rise in death rate, which with increasing heat versus increasing cold, typifies the temperate zone relation. So in the temperate zones at these latitudes, typically heat waves bring more casualties, as we saw in the 2003 heat wave in Europe, which led to excess of maybe over 75,000 deaths, which is very unusual for such developed countries, and France especially paid a very heavy price. And again, there is socioeconomics involved, lack of information, lack of acclimatization. For example, even if you look at the difference between Sydney and Brisbane, Brisbane is north and people are used to warmer temperatures than Sydney, for example, or Melbourne, for example, and such things are important because acclimatization does matter especially over time. The other thing is sea level rise. The consequence of global warming is very severe in terms of sea level rise, which obviously causes inundation, king tide, storm surges, erosion, soil, groundwater, salinization, and so on. But this figure from this paper here is looking at spatial and or temporal variability in perception of risk, whether it's sudden to gradual and reactive to anticipatory, so reacting when the change happens versus anticipating changes, and how it projects onto environmental, political, social, demographic, and economic spheres. So here impacts on employment opportunities and livelihood. So all these are in the context of how they drive migration or the decision to stay, the risk perception. So policy incentives manage to retreat. So these are kind of the options that political actions can take. Social, education seeking, family, kin obligations, and demographic impacts include population size and density, urban versus rural, age structure, socioeconomics, and we can go back to even the periods of Vikings settling the Greenland, for example, and when it got colder, the younger ones probably would have left, whereas the older ones probably would have decided to try to live it out, right? And they eventually had to abandon Greenland and go extinct. Okay. Here, individual and household depends on preferences, wealth, age, sex, wage seeking, employment opportunities, loss of livelihoods, increasing vulnerability, institutional failure. All these things are involved in driving decisions, including obstacles and facilitators. So protection, accommodation, and retreat, which again depends on things like per capita GDP and so on. Okay, so this gives us a sense of how human ecology is affected by the climate change, sea level rise in particular, and migration, and that includes conflicts as well. When people migrate into a new region and there are resource limitations, then obviously there will be conflicts. Just as an example, we can look at the history of malaria here. I'm just going to run through this long timeline. The timeline for origin of malaria is considered to be 500 million years ago, when existence of a pre-parasitic ancestor would have occurred. Zooming down to 150 to 200 million years ago, early dipterans, ancestors of mosquitoes, would have appeared. 130 million years ago, two host life cycle in dipterans and vertebrates evolved. So mosquitoes, mosquito ancestors began to transmit the parasite to vertebrates. Divergence of the bird and mammalian malaria parasites would have occurred. Lineage of Plasmodium malariae, Plasmodium ovale, Plasmodium vivax. We have Falciparum now as well. Then 5 million years ago, Falciparum evolves. 2 to 3 million years ago, divergence of vivax and Cynomolgi. 4,000 to 10,000 years ago, coming into the Holocene, lethal strain of the Plasmodium falciparum appeared. 4,000 to 5,000 years ago, Anopheles in Africa developed highly anthropophilic habits. So mosquito itself, living in the wild, then got used to human beings and found a suitable host, which changed the game forever, right? Timeline for spread of malaria now. Malaria in Africa, Mesopotamia, Indian Peninsula, Southeast Asia, China. Falciparum reaches India about 3,000 years ago. Malaria reaches the Mediterranean shores 2,500 to 2,000 years ago. So Falciparum prefers tropical warm temperatures, whereas Plasmodium vivax can live in colder temperatures. Malaria reaches northern Europe, New World. Malaria spreads across North America in the mid-18th century. 19th century AD, malaria almost all over the globe then. Also malaria, early 20th century, millions die of malaria almost all over the world. By the early 1950s, malaria almost disappears from North America and from almost all of Europe. Deaths mainly occur in Africa even now. You remember DDT, which was used as a pesticide and something to kill mosquito larvae, was found to be a carcinogen. Silent Spring from Rachel Carson from the 60s, which led to the ban of DDT, which didn't happen till the 70s. But now, because of continued malaria infections and massive number of deaths in Africa, there is some discussion about bringing DDT back in limited amounts to actually take care of mosquitoes and so on. So this is a good example of how the coevolution of the pathogen, the host, or the vector, and multiple hosts in terms of birds and animals and humans, and how mosquitoes themselves evolved to live on humans as agriculture evolved, vegetation changes, deforestation, and so on happened. And that's a good example of how intricate the human ecology can be. As a last point, now things are even more complicated. So, because of habitat changes, temperature changes, humidity changes, migrations, and travel, globally connected communities can get around very quickly by flights and other modes of transportation in continental level by trains and buses and so on. There are conflation or confounding of various factors. So COVID-19, which probably is related to bats transferring the virus to some other animal to humans, or the debate goes on about whether it escaped from a lab and so on. Nonetheless, you can see that estimated percentages of COVID-19 mortality attributed to air pollution from all anthropogenic sources and from I think fossil fuel burning alone shows that there is huge comorbidity issues. So people who are living in polluted areas and exposed to pollution are actually experienced much higher mortality due to COVID-19. So this is an example of just how complicated human ecology and human interaction with the habitats, animals, birds, and hosts of co-evolved viruses. Bats have co-evolved with literally thousands, if not more, viruses which don't affect them. But if humans contract them, then obviously humans suffer a lot, as the pandemic has shown several times, from HIV to SARS to bird flu to Ebola to now COVID. So these are the things we are dealing with when we talk about the choreography of climate and human health and disease outcome. Okay?